All right, welcome back to another episode of Learning with IPv Dre. Today, we are going to discuss how to quickly configure and verify single area OSPF. And emphasis on quickly. I'm going to try to do this as quickly as possible because I want to keep these videos tight. I want to keep these videos short and palatable, if you will. Still following the same format for gotta just bring this camera up. Still following the same format for as if I was streaming, no edits, no cuts, and none of that stuff. Because I like this format. I actually love doing this. So we're gonna be putting some, more effort into getting the live streaming thing going. I'm feeling pretty confident that I could live stream. Maybe I think I could do it within another month or so. Probably just start live streaming this stuff. Also, depending on the engagement on this channel, whether you guys will tune into the live streams or not. We're typically going to be doing more technical content on the live streams. Currently, I am at 593 subscribers, which is amazing. I did not see myself getting this far so quickly. That goes to show that you guys appreciate the content. You guys are getting value from the comment. I get a lot from the content. I get a lot of comments from you guys saying that you get a lot of value. I'm glad you get a lot of value. So I'm gonna keep on doing this content as long as I can before I get snatched up by an employer and start having like a full-time job, right? But this is always gonna be a staple in what I do. I love to teach, I love to learn with you guys, and I love to share my journey and the gems along the way, right? Learning and growing together. So if you are new to this channel and you haven't subscribed yet, you should definitely subscribe because I'm going to be doing a lot more technical content, as you can see in this video here. And you'll get a lot of value out of it because I'm learning as you're learning, right? It's not necessarily a course, anything of that nature. This is more so getting your feet wet. You can follow along if you want. That's the whole purpose of me doing this format of content, where you can, go grab your laptop real quick or turn on your computer and, just follow along. And I will be making mistakes along the way. I am not perfect, but I have a notepad set up right next to me on my second monitor. Fancy, right? And I'll try to stay on subject as much as I can. I'm very much excited about the networking stuff. So make sure you like the content. Make sure you subscribe. Make sure, or if you don't like it, dislike it. That's fine with me. Comment, tell me what you like, what you didn't like, what I could do better. And let's get into it. So let me just share my screen real quick. So basically what we have here is we have Packet Tracer. So if you don't have Packet Tracer, download it now. Because before we get into the configurations, we are going to talk about some basic OSPF concepts. Let me unshare my screen so that you guys can see me. So we're gonna have to define some basic concepts, set some groundwork before we start configuring OSPF, right? And this is one of my favorite topics because dynamic routing and routing period is near and dear to my heart after trying to configure a whole network or configuring a whole network with static routes last year. I did it in this video right here, and it was quite annoying, and I don't want to do that again. I don't want to do that again. I want to be using dynamic routing protocols forever, right? And if I can help it, learn automation as soon as possible so that I don't have to be a command line jockey, right? So OSPF is a dynamic routing protocol. But what is dynamic routing? We have dynamic routing and we have static routing. Static routing is manually configuring routes to a destination all by hand. Like you're just configuring the routes and entering it into the routing table by hand manually. And if you have hundreds of networks, like that's not going to work. That's not feasible. So we have been blessed with the dynamic routing process, and we have a few dynamic routing protocols. OSPF is one of them. So what is dynamic routing? So dynamic routing allows for routers to share information about routes to destinations they know about to other routers, right? They have to form neighbor relationships in order to share information. This sharing of information is known as advertisements. So essentially, routers basically share information about other routes dynamically, automatically, without us having to do anything beyond setting up the routing protocol process on each router, right? So in the old days, you have to go to each router, which is what I'm pretty much doing, and setting up the routing process. But nowadays, it's different because we're using automation and programmability and using Python scripts and all that stuff, Ansible, to push the configurations to each device automatically. And again, we're going to be working on that probably, I don't want to say next week, but after we finish the Active Directory stuff. We're taking a little break from Active Directory for today to do some OSPF, some networking stuff, right? Learn networking with IPv4. So there are two types of dynamic routing protocols. We have IGPs and we have EGPs. IGP stands for Interior Gateway Protocols, which consists of OSPF, EIGRP, IGRP, RIP, and ISIS. ISIS stands for Intermediate System to Intermediate System, which is used typically in greenfield SDA designs. Now, you're going to be learning about greenfield later on in your CCNA studies, or you probably already learned about greenfield designs, but just know that greenfield designs use the ISIS routing protocol, right? It allows for the the switches to not have to use STP, which could be a headache in some cases where you have a bunch of switches. You could just simply use some layer 3 switches in this design and configure the ISIS routing protocols between each switch, and don't have to worry about STP and all of that stuff, right? So IGPs advertise routes within an autonomous system, AS for short. So what is an autonomous system? An autonomous system is simply an organization. It's simply an organization's network. And simply put, OSPF, EIGRP, IGRP, RIP, ISIS are routing protocols that share routes within that autonomous system boundary, if you will. On the flip side, we have EGPs, Exterior Gateway Protocols, and they consist of path vector routing protocols. And the only one that's in use today is BGP, Border Gateway Protocol. I believe some months back, was it in October? I forgot when it was, but it was some months back that I guess Facebook had an issue with their BGP protocol or something like that on one of its routers. I don't know. I don't quote me on that, but I believe that's what was surfacing, that what was being propagated around the internet. Memes were made about it and stuff like that, right? So again, the only type of EGP in use today is a path vector called BGP, right? Now, what is OSPF? We said that it's a dynamic routing protocol, and that's pretty much all we know about it so far, right? So OSPF is a link state dynamic routing protocol. Another link state routing protocol is ISIS, intermediate system to intermediate system, right? In contrast to link state routing protocols, there are distance vector routing protocols. So let's go more deeply into link state, right? What are link state routing protocols? So link state routing protocols have their routers create a network map. So routers essentially with link state routing protocols, they share information about each other's interfaces and a few more other details, right? But at the basic root of it, each router is sharing with each neighboring router, neighbors, because they're forming these neighborships, information about their interfaces, whether it's up or down, and also the local area networks, if any, that are hanging off of their LAN interfaces. And each router keeps on sharing this information until each router gets a full picture of the network, called the network map. You could call it a network map or a network connectivity map or something along those lines, right? So once it creates this network connectivity map, once each router has a full picture of the network, each router can then calculate their routes to each destination network, right? So let's see here. Let's continue. This map is constructed from information that other routers share, such as info about networks hanging off of their interfaces connected to neighbors, which are other routers, which I said just now. Let's continue. Got some notes over here. From this information, each router builds their own routing table, which consists of destinations to each network, as I said before, from their own perspective. Link state protocols are CPU intensive because of the density of information. Be careful with those debug commands, right? That's why I put that little note there, right? So first things first. Each router, again, gets a piece of the puzzle to this network connectivity map puzzle, if you will, right? And these pieces of the puzzle are called LSAs. So again, it depends how all of this works. It depends on the network type of OSPF, but we're gonna assume that each router is flooding their LSAs to each other router, right? So each router is flooding their LSAs to other routers. LSAs stand for link state advertisements, right? They're sharing information about its own network, its own interfaces and everything. And each router gets a piece of each router gets an LSA from each other router, and it creates this big network connectivity map. And then each router is responsible for calculating routes to each corresponding destination, right? So it does this using something called SPF math, which calculates the metrics to each other network, and you have your routing table. Also, all of these LSAs are organized inside of an LSDB, link state database, and the LSAs are essentially data structures, right? They're not actually routes. They're not actually detailed information about routes that exist, like routing tables that exist in each router, if you will, right? And correct me if I'm inaccurate or wrong, but this is to my knowledge, right? So that's why the link state routing protocol is so intensive, because so much information is being propagated from interface to interface, and it uses up a lot of CPU cycles. Oh, also a story that I had come across, I believe it was on David Bomble's channel, where he was interviewing a guy that's been in the field for a very long time, and he said he had asked him what mistakes he's made along the way in his networking journey, his IT journey. And he says that one mistake that he had made was issuing a debug command on a router that was responsible for connecting a country to the internet or something like that. So he issued this debug command, which essentially, I guess, the router essentially just crashed because it flooded the router with so much data that it couldn't handle it, right? So got to be careful with those debug commands. I'm going to be using a debug command in this video here. I mean, it's packet tracer we're working with. So I'm going to be using a debug command to, get familiar with what the OSPF process actually looks like check under the hood to actually look at the messages being propagated from router to router, right? So we're going to move on to distance vector routing protocols. What are distance vector routing protocols? So distance vector routing protocols are known as routing by rumor. This is where the routing processes share the routing tables with their neighbors, right? With the router's neighbors, right? And essentially, distance vector routing protocols allow for routers to share their routing tables. They share their known destinations, and they share their metric to reach their known destination networks. Some examples of distance vector routing protocols are EIGRP, which is Cisco proprietary, and RIP, right? RIP has 3 different incarnations of it. It has version 1, it has RIP version 2, and it has RIP next generation, right? And as we said here, EIGRP is an example of a distance vector, although it's called advanced distance vector, right? So that's basically the basics of OSPF. Hopefully I didn't butcher that too much. I'm just trying to stay really basic for now, because I just want to get into what you need to know for configuring OSPF rather than getting too caught up in the details, even though these details are what you need to know for the CCNA, to be fair. But this is not a course, this is more so just a little demonstration, right? Because I love networking so much. Now, as you can see, we have 2 routers, 2 switches, 2 hosts. This is a very simple setup. This is not a complicated setup at all. I'll just be using 2 VLANs, one here and one here. I was so tempted to throw in router on a stick or using a layer 3 switch, and I decided to just keep it as simple as possible, right? So what I advise that you should do before you do any configuration, any setup, is you should write down your IP address scheme. You should be planning everything out like I did with my notes. I set up a nice little notepad. I have my IP addressing scheme. I have the scheme I'm going to be using on the point-to-point link. I'm going to be using a point-to-point link between these 2 routers. I have the IP addresses that I want to give each respective VLAN. I even threw in a little bit of Dhcp there, made sure that I had those bearings straight, and it really organizes and makes your configuration a lot easier if you have a plan rather than configuring everything from memory, right? So that's a best practice, in my opinion, if you're going into the command line and you're configuring anything, right? So let's jump into the command line. I'm seeing if I forgot anything. Oh, let's jump into the command line. First things first is we're going to start with router 1, right? And just to let you know, I'm going to be using abbreviations of commands such as enable, configure terminal, the show command, and interface, things of that nature. I'm using a lot of abbreviations because I don't feel like typing all of them out, obviously. So enable conf t. Let's change the host name to router1, right, with the host name command. And I'm also going to try to explain the commands as I go along. Now we're going to jump into interface G00. Yeah, interface G00. IP address 172.16.1.1, 255.255.255.252. Put too many S's there. See, and that's the thing I love about Packet Tracer to iOS. iOS shows you where you put it. You know, if you type in the wrong command or you make a typo, it shows you right there. That's how I was able to identify that really quick, right? So basically with this, put no shut. And I'm gonna explain the no shut command in a second. This right here is a /30, right? Which is gonna allow us to create a point-to-point link between these two routers without wasting IP addresses, right? We could have done a /24, but we'd have been pretty much wasting 252 IP addresses, right? With a /24, you get 256 IP addresses, 2 which are reserved, which is 1 for the subnet number, 1 for the broadcast address, and then you know, the rest of is yours. So you have 254 left over for applying them to nodes, hosts, servers, whatever. But we're only going to be using 2 IP addresses, which, you know, there's no need to be burning wasting all those IP addresses unnecessarily. 252 to be exact. You're going to be learning more about that. If you haven't already, you're going to be learning more about that when you really get subnetting, right? So yeah, the group size is going to be, as you can tell with this number right here, is going to be 4 IP addresses, because it's going to be 256 minus 252. You're going to be left over 4. Got to reserve 2, 1 for the subnet number, 1 for the broadcast, and then the last 2 is going to be 1.1 and .2 for our point-to-point network that's between these 2 routers, right? Now, the no shut command. Some of you that are watching this might be a little bit new, but the no shut command is interesting because it's speaking to the current or default condition of the Cisco router. So Cisco routers interfaces are shut down with the shutdown command by default. When you issue no shutdown, you're essentially reversing that command or removing that command and bringing the interface up. So in many instances, when you put no in front of a command, it cancels out that command. So say for instance, if I put no IP address, it's going to remove the IP address from the interface, which we're not going to demonstrate right now because we want to move on, right? So we set up the IP address for the interface that's going to be connecting to the other router, which is going to be its neighbor. Now, very important point to remember for OSPF configuration in order to successfully configure OSPF. 2 things you want to look out for. Matter of fact, 3 things you want to look out for. The third thing we're going to talk about when we get to the OSPF routing process. But first thing, you want to keep in mind there's going to be 8 things you need to look at and make sure it's in order before to make sure that you can form a neighbor relationship with your routers. Make sure your routers form their neighbor relationships, right? First one, got to make sure that the interfaces are in an up state, which is what we're doing with this no shut command and applying the IP address to it, right? You want to make sure that the routers are in the same subnet, which is what we just explained with this /30 mask, right? That allows for 2 IP addresses on that point-to-point link. I believe this is a point-to-point network by, no, not by default, but it's a point-to-point network. And yeah, the third thing, you want to make sure that both of the routers are in the same area, right? Another thing you want to make sure is you want to make sure that no ACLs are filtering routing protocol messages. Fourth thing, make sure that the OSPF process is not shut down, which it shouldn't be, but for some reason if that might happen sometime, I don't know what case that might happen, right? You want to make sure they pass routing protocol authentication if you have these authentications commands set on your interfaces. Make sure that the hello and dead timers match. The RIDs, the router IDs must be unique. You're going to see what we're talking about with regard to router IDs in a second. They must be in the same area, and OSPF processes must be up. What else? Yep, that's all 8 of them, right? So what are hello and dead timers? Hello and dead timers. OSPF is really deep. Hello and dead timers. A hello and a hello timer is the interval by which a hello is sent to the other router. So basically, routers try to feel around for each other. That's how I think about it. They try to feel around for each other to make sure to monitor each other's status, right? The dead timer is the interval that goes by or elapses after not receiving a hello message from the other router. So basically, the default hello and dead timer is 10 seconds and 40 seconds, right? So the dead timer is 4 times the hello. If 40 seconds go by without a neighbor receiving a hello, that router is going to assume that the router went down and the convergence is going to have to happen at some point, right? So that's what the hello and dead timers are. And the hello and dead timers must be set with the same settings on each router, right? Hope I'm not going too fast. Maybe I should slow it down just a little bit, right? So that pretty much sums that up for what you need to know for making sure that the neighbors are, the neighborships form between each router, right? And if you're watching this video, I'm assuming that you have some idea of OSPF and you're learning about it, or else you probably wouldn't have clicked on this video. But I'm not gonna go too much into details for a lot of these things with regard to OSPF, because at some points we can venture into more advanced topics, but I want to keep it to like CCNA level stuff. Plus, I need a refresher on all of this stuff, and I need to really get into CCNP, because CCNP is next on the list. Oh, by the way, let me show you guys something real quick. So this is the book. It might be reversed. This is the book I'm using for CCNP, right? I believe that everybody should get good textbooks to learn from when they're studying for their exams. And I'm starting with that textbook. I'm also going to be using networklessons.com after I get through that book. Also going to be using a lot of white pages and Boson. Now, if you're studying for the CCNA, this is the book that you should be using for your commands. If you're having troubles remembering commands and issuing commands, this is a good book to go to help you along, right? It's called, because I know it's reversed. It's called the CCNA 200-301 Portable Command Guide, right? So there's that. Now let's move on. Let me remember to share my screen. All right, so, okay, we're good. Now, so far, all we did, we're gonna have to move through this pretty quickly. So all we did so far is put an IP address on router 1, right? It's saying, well, router 0, but router 1 on that node. So now what we're gonna be doing is we're going to be issuing commands for the LAN facing interface. We're gonna set that network up. Let's do this. 10 dot, what's it gonna be? 254. 255.255.255. Oh, no shut. It's up. That is gonna be the IP address for G01, which is the LAN facing interface. And now we're gonna set up a DHCP. We're gonna set up a DHCP server on this router to give out IP addresses for the host on this network, right? Or the host that's a part of this network, right? So you're gonna use IP DHCP pool. Pool name is gonna be VLAN 10 network. This is gonna be the range of IP addresses that this DHCP server should be giving out. Now, if you want to be fancy with your DHCP, or not even fancy, but if you're really in the weeds of DHCP configuration, what you want to do is, what you might want to do is, and then we're going to set a DNS server. Use, I think this is Cloudflare, I think. You can set ranges where the DHCP doesn't give out IP addresses, and that command is IP DHCP excluded address, I believe. Let me double check. IP DHCP excluded address, and you set the range of IP addresses that you don't want DHCP to lease. And that's typically for servers, printers, anything that needs a static IP address. We explained this in the Active Directory videos, where we explain the necessity of having a static IP address for our domain controllers, right? So this is where the magic happens, right? You can put, you can set aside a certain range of IP addresses that the DHCP server is not allowed to lease, and you can also set the lease times for other, for the dynamic IP addresses, and you can do that by using the lease command, I believe. Yeah, you do that using the lease command, right? Now we set the DHCP server. Set the DHCP server up. Let me make sure that I have the right settings. I hope I do. Now we're going to go into the OSPF process, right? Router OSPF. Now there's a shortcut for doing this, but we're not going to use a shortcut yet. Show you a few things. So basically what we're doing here is we're going into the OSPF process using the router OSPF 1 command. So basically the syntax is router, and then you're using the OSPF, you go into the OSPF process, and 1 is the process ID. Now the process ID is only what you would call locally significant, right? They can match on various routers, or they don't have to match. They don't have to match at all. It's only relevant to that local device. When we get into configuring EIGRP, this is going to be, it's not going to be a process ID, it's going to be an ASN, autonomous system number. And these have to match amongst the routers, right? So that's pretty much how that works. Just have to check on something real quick. Okay, so we got the router OSPF process ID, which is 1. We're going to use 1, right? Now the network command. What does the network command do? The network command essentially tells the router, it essentially tells the router where to advertise, or where to activate OSPF, right? Just gotta look at some of my notes here, right? Want to make sure that this is accurate, right? So it essentially tells the router to look for interfaces with IP IP addresses within a specific range, right? And it activates OSPF on the interface in that specific area, right? So it also tells the router to attempt to become OSPF neighbors with the connected interface, right? Where other neighbors are, they have, assuming they have OSPF activated on that interface as well. Now, I went through the 8 things that you need to make sure are checked in order for that to happen, because if you don't have those 8 things checked or within compliance, then it's not going to form a neighbor relationship, right? So we're going to activate OSPF on the interface that's connecting router 1 to router 2 on that point-to-point link, right? So we're going to do 172.16.1.0, and then we're going to be using this wildcard mask. Now, we explained what a wildcard mask is, I believe, in another video. Wildcard mask is simply the reverse subnet mask, right? So in the point-to-point link, we specified that we're using a 255.255.255.252. The reverse of that is 0.0.0.0.3, right? And how you get that is you subtract this from 255.255.255.255, and you're gonna get 0.0.0.0.3. Now, that's a very, very simplistic way to explain it. But again, what the network command does is it's telling the router to look for IP addresses in this range and activate OSPF in that range for interfaces in that range, right? And then it's gonna be in area 0, right? So boom, we got this command. Boom, OSPF is activated on our G00 interface because this network command specified this IP address, right? It falls, this IP address falls within this specified range, right? Whew. Now we're gonna do the same thing for the LAN-facing interface, right? So this is going to tell OSPF, it's going to tell the router to activate OSPF on this interface as well, and it's going to advertise about that network, right? Boom, we got that. Next command we want to put in, passive interface int G01. Oops. Did I screw up something? Passive interface. Where's the error at? Oh, I made a boo-boo. What is the... I think that's it. Yeah, there we go. I put interface twice, right? So what does passive interface do? Passive interface basically tells the router not to propagate any hello messages out of the specified interface. Why? As we mentioned before, OSPF is a link state process that is a link state protocol that is already very CPU intensive as is. So to make the OSPF process more efficient, save resources, we're going to issue the passive interface command, which prevents any hello messages from being propagated out of that interface because it sucks up resources, right? Unnecessarily. Also, again, what's the rationale behind that? Why? So you're expecting on G01, you're expecting that there are no other routers to become neighbors with on that interface, right? So why would you send a hello message out of that interface, right? It's essentially making the OSPF process more economic, if you will, and it's logical. All that exists off of that interface is probably some printers, servers, I don't know, IP phones, laptops, desktops, maybe some wireless devices if you have, if you have wireless devices and stuff like that. If you have wireless access points set up and all that stuff. So that's essentially what that is, right? So now we're done. We're done with router 1. Let's go into router 2. Enable conf t. Let's change the host name, router 2. We're gonna go a little bit faster here. G00, IP address 172.16.1.2, 252, right? No shut. Also, I wanted to show you what the no shut actually does. When I said that the shutdown command is issued on Cisco router interfaces by default, this is what I meant. Do show run. Okay, what is do show run? So do allows for you to issue show commands from wherever you are in the CLI, right? So I hit do show run. Show is abbreviated with SH, and run, running config, we're using run, right? Boom. So you can see, let's see, by default, yeah, right here. Interface G02 has the shutdown command issued by default. See, this is the running configuration. This is what it's currently running right now. So let's see what happens when we do no shut for G01. So we see G01 with the shutdown command, right? So int G01, let's put no shut, it's up, right? Now let's do show run, and let's see what it looks like. So for G01, it removed the shutdown command. That's essentially what the no does, right? The no pretty much cancels out the command that's issued on the in the running config, right? Also, let me do something real quick. Logging synchronous. The logging synchronous command is very useful because it keeps us from being interrupted by the messages that the router wants to send us as we're working in the CLI, right? So now we're gonna issue an IP address on it, 192.168. Make sure I got it right. I like to follow my IP addressing scheme, even though I have it stored in my head. I want to make sure that it's in my mind by default. I mean, I want to make sure that I'm following it by default, despite the fact that it's in my mind, right? So we already issued a no shut. Just want to make sure, right? Exit. So what did we do so far? Make sure. Yeah, we already did this, right? That's for the point to point. And then we set up the LAN facing interface to make sure that they're getting connectivity, right? So now we're going to set up the DHCP server on this router. Now I'm well aware that I could have simply put the DHCP server on one router and use the helper command to let it give out IP address. I'm well aware that I could have set up the DHCP server on one router to give out IP addresses for the whole network, but again, we're keeping it as simple as possible. And again, that's something that you're going to learn down the line when you're further along in your studies. It's another exciting topic. It's a very exciting topic. All of the CCNA is exciting. I really love this stuff. This stuff is really cool. Now let's set up the DHCP server. IP DHCP pool name, which is going to be VLAN 20, right? Network. This is going to be the network of IP addresses that the DHCP server is allowed to give out the default router by which the hosts have to send packets to if the destination is not in its network. DNS server. And since I've been running my mouth, I really like to make sure that I check the configuration so that I have, even so, I mean, even if I made a mistake, we can always come back. Now, let's do this. So, router, here's an interesting, so remember when I said that you have a few choices, right? For, first you have a few choices as to how you want to activate. I mentioned the shortcut as a matter of fact, which meant that you have a few choices as to how you want to activate OSPF on your interfaces. You can issue the specific ranges of network commands, or you can just activate it on all interfaces with one simple command, right? But even before that, router ID. The router ID, you can configure, three different ways, right? You could do manual configuration, highest IP address on the loopback interface, and highest IP address on the physical interface. And it takes a certain precedence. The OSPF process or the router would much rather a manually configured router ID over the highest IP address on the loopback interface and highest IP address on the physical interface. Loopback interface IP address takes precedence over the highest IP address on the physical interface. So it's a order, it's a tier of order of priority, right? Or order of preference, if you will. So now what we're going to do is we are going to configure the router ID. Which way should we do it? We can, you know what? We're gonna do it. We're gonna do it manually, right? So router OSPF 1 router -ID. Let's see if we can do 200.200.200. I want it to be bigger than I want it to be, the reason why I'm doing that is because I want it to be, well, you know what, let me not even, because that's a different story. I'm jumping ahead. So network, right? So this is what we could do. We could just activate OSPF on all of the interfaces by doing this. Oops. Invalid mask, oops, right? So what this says is basically, hey, just activate it on all interfaces, right? Not gonna go into the logic behind here because that's a whole other subject. Don't wanna make this video too long. This video is already going on. Yeah, we're gonna hit an hour on this video. Sorry. But yeah, so we just activated with one command OSPF on every interface by doing this. This essentially says match all interfaces, right? But remember, we want to conserve resources, so we can do passive interface G01, right? And that conserves resources for that router, right? So let's see. Okay, yeah. I was wondering why it wasn't coming up. Then I remembered I didn't connect everything. So we did all of this. Usually when you, and we're gonna see this in a second, usually when you connect everything up already and you issue those commands, the CLI will tell you that, oh, the OSPF process is up and the router's in a full state or whatever, right? So we're gonna go ahead, and this is important too. You need to know this for the CCNA. When you're connecting two of similar device types, you're gonna use a crossover cable, right? So we can connect G00 to G00, and then we're gonna watch it come up. You can see the OSPF process should be coming up soon. Let me see. Should be coming up soon. I should have connected them before so they could have come right up. And just to jump ahead, you know what? Let's connect the other stuff and come back and see if it comes up. All right, so two different devices. We could do G01 with G01, G01 with G01, and then we can do another, yeah, forgot to mention the name of them. These are straight through cables, right? Straight through cables. Use a crossover cable for similar devices, straight through cables for different devices, right? F01, F0, I think that's F what, 00? Yeah, F00 to F00. It doesn't really matter. F00 to F01, doesn't really matter, just connect them up. Also, another thing I want to mention, why that is the way it is. So the reason why I'm using a crossover cable here is because these routers both have a NIC and they transmit and receive on the same pins, right? So what you want to do is you want to use a crossover cable so that it crosses over, so that it flips, so that it's transmitting so that router 1 is transmitting to router 2's receiving, and router 2 is transmitting to router 1's receiving. Crossover, so it's crisscross, right? So that's called crossover cable, right? So now let's see if it went up. Yep. This is another thing you need to know for the CCNA, right? You need to understand what this is. These are the, dang, what are they called? Ooh, forgot, but you need to know what each of these sections are, right? This is the timestamp, the facility, the severity. With this 5 is notification. This is a mnemonic, and then it tells you the message, right? It tells you what happened. It's very important that you're gonna learn this when you learn an NTP. You wanna make sure that the time is correct, because we're on router 1 right now, right? So we see that the process is up. They went up pretty much, I think they got the similar time, but these times need to be synced up. So that's what you're gonna be using NTP for. Now, let's see real quick. First of all, let's verify, right? Because CCNA, Cisco, all of these network engineering topics, it's about configure and verify. You cannot configure without verifying. You need to learn how to verify as well. Very important too. So let's go back to, we can go back to the enable mode. Let's do, because I don't want to type do show all the time. You can just issue a regular show command, show IP OSPF neighbors, right? Oops. Show IP OSPF neighbor, is that it? Yeah. Sometimes you bumble through it, right? Okay, so now look, see, we verified it. It's saying right here, do I stretch it out some more? Yeah, I stretch it out. Let's just do this. It's saying that router 2 is neighbors with this neighboring ID right here. So router 1, I didn't configure a loopback, nor did I configure a router ID. I didn't configure neither one of those. So it took the least preferred method of router ID configuration by using the highest IP address configured on an interface. It used this number right here, this IP address right here. That's what it's being identified. That's what router 1 is being identified by. So wait a minute, let's see what happens if we change that. Let's change it. So on router 1, and this is, I'm getting into the weeds. I'm getting into the weeds here, the details. Enable conf t router ospf1, we enter into the ospf process of 1, and then let's change the router ID. Router ID, let's do 8.8.8.8, right? It tells you, I didn't know it was gonna send us this message. It said reload or use clear IP ospf process command for this to take effect. That's essentially what you have to do in order to change your router ID. Now, I'm not going to get into non-preemptive, preemptive, all that stuff, but this is essentially what you have to do because it's not going to change it immediately, right? Let's do, let's go over here. Let me show you, right? Up, press the up arrow. It didn't change, right? It didn't change. So the router ID is still the same. Now, let's do router OSPF and let's do clear IP OSPF process. What happened? Oh, do I have to go back? I think I have to do, I have to go into you have to do this from the privileged exec mode. Clear IP OSPF process. Yes. See? It cleared the process. And here's the thing, like, practicing this stuff is very important because after a while it becomes intuitive. Like, I kind of low-key knew that I had to go back to the privileged exec mode, but I forgot, right? So let's see now. Let's go into the other router and let's check. Show IP, see, it changed. Show IP OSPF neighbor. So you're gonna see the neighbor ID. You know that OSPF works, right? Because first of all, you got this message right here. And then it gives you some information. It says you connected to neighbor ID 8.8.8.8, priority 1, which I'm not really gonna get into full. It's in a full state. And the other router is the BDR. The reason why it's the BDR is because it has a lower router ID. That's how it figures out who's gonna be the DR, BDR. I don't wanna get into all of that stuff. And then it shows the IP address, the interface. And that's pretty much how you configure, that's how you verify, right? You can also do show IP protocols, right? Boom. You see, of course you see the AD is 110, but you can see that OSPF is running on this, right? Because this has router ID, maximum paths, not gonna get into that. Routing for networks, this means all networks. Passive interface, G01. And it shows routing information sources, right? This is interesting because we changed this and it's still showing these are the same routers, but I guess this is just the most recent updates, right? Or it's a record of where it got routing updates from, right? So there goes that. Now let's try something. Let's try something interesting. So let's go into. I'm about to screw this up. Let's go into the routing process. Router OSPF 1. Passive. Remember passive interface? Passive interface G00. Let's see what happens when I configure this, right? Oh, neighbor went down. Interface down or detached. The reason that's happening is because, like I said, we need these hello messages to be propagated back and forth between the routers so that they have a constant tabs on each other, right? And when you initiate or issue the passive interface command on an interface that has OSPF activated on it, it blocks those hello messages from being propagated out of that interface. That's essentially what happened here. So now what we're gonna do is we're gonna press up, Control A to go to the beginning of it, and now we're gonna hit no passive interface G00, and it should come back up. Let's see, because I've never done this before. Yeah, there we go. It comes back up. It goes to say, and it goes hand in hand with what I was saying earlier. When you issue the no in front of a command, it cancels out the command, and as you can see, that's what happened here. It brought it back up. Now I want to show you, I think, one more thing. So I showed you how to configure. Let's just recap real quick. We talked about the basics of OSPF, right? We talked about link state routing protocols, distance vector routing protocols, and setting up the basic network or what have you, right? And again, I appreciate OSPF so much because, as you can see in this video right here, I went ahead and configured all sorts of, or is it up here? I'm gonna show it. I think I'm gonna show it up here. Either up here or up here. You probably see it. I configured a whole network with static routes, which was a nightmare, right? And I had so many issues, right? So I totally appreciate OSPF because we don't have to configure manual static routes by hand. All of this happens automatically, and the routing tables are filled up with the necessary, with the known networks, right? The advertised networks. And let me show you that right here, how that happens without us entering IP route. The IP route sets the static route for a router, that injects a static route into the routing table. But let's see, do show IP route. So this is the routing table, and we can see that OSPF is working, right? C stands for connected because it's directly connected to, C stands for connected network because you have this right here directly connected to G00, which is that point-to-point link, right? And we have local because we configured this IP address on this interface, right? So it uses a /32, which means 255.255.255.255, right? O stands for OSPF, and it learned this network from this router right here, right? So it learned this network via this router. This is the administrative distance. This is the default administrative distance, and this is the metric, right? You can change the administrative distance if you want, if you have a preferred routing protocol that you want to set up, that you can say you set up EIGRP alongside OSPF and you prefer OSPF over EIGRP, you can change the administrative distance here, and you will have the OSPF routes in by virtue of that distance command that you set in the routing process, right? Yeah, we're an hour and some change in. I want to show you that I'm tempted to show you that real quick, but we're not gonna do that. We're not gonna do that. What was I showing you? So this is the routing table, right? This goes to show you that OSPF worked. It worked. Maybe in the next video I'll do that. But this shows you that OSPF is configured. It works. This is another way to verify that OSPF is working and advertising the routes that it's supposed to advertise, right? Connected, directly connected to its own interface, directly connected to one of its own interfaces, right? Boom. That's how you read the routing table. Make sure you get really, really, really comfortable with reading routing tables. This is your bread and butter. One of your bread and butters, right? So there's that. Now I'm gonna show you. You know what? I want to show you something with the routing table. I'm sorry, this video is gonna be long, but hey, hopefully you guys stick around. Let's configure EIGRP. Router EIGRP, and we're gonna do the AS number of 1, right? Network, we're gonna make this real quick. O 255.255.255.255. I'm gonna show you something real quick. And it's gonna give you a hint as to how the router makes, how the router builds its routing table. So, boom. Oh, wait, what happened? What did I do? Oh, it doesn't use, EIGRP doesn't use areas, by the way. Right, boom. So we have that configured. Let's exit. That's pretty much all we have to do to configure EIGRP. Just quick, right? I mean, there's other things you have to configure, but let's do this real quick. Oops, we're already there. Router, EIGRP. Remember, the AS numbers has to match. AS numbers match. Network, 255.255.255.255. Boom. See, new adjacency, just like that. Boom. Right? That was super quick. Right? Again, learn how to read these messages. Facility, severity, mnemonic, and this is the description of what happened. Right? Now let's go back over here. Let's do show IP route. Now you see here that it's showing EIGRP, right? But we see a D. The D stands for dual, right? I forgot the exact details behind dual, but yeah, that's how you know you're using EIGRP. That's how you know that the router has EIGRP routes in the table, right? Now, remember earlier I said, you know, maybe I want to use OSPF routes in this routing table, right? How do we do that? Simple. Go to router, OSPF 1, distance, and you have to set it something that's lower than the default administrative distance of, or the current administrative distance of EIGRP, which is currently 90. This is more for people who are more, I guess, along in the CCNA studies. I just couldn't help it. I love this stuff, right? So distance, let's put 85, right? We're changing the administrative distance of, we're changing the default administrative distance of the OSPF process, right? Let's exit out, and we're gonna do show. See, now we see that we're using OSPF routes, and it's AD. So basically, it's a little routing lesson here. How Cisco routers build their routing tables. So a Cisco routers, or I think routers in general, but Cisco routers prefer routes from routing protocols that have a lower administrative distance. As you can see, EIGRP took over once we configured it because it has an administrative distance of 90, while OSPF has an administrative distance of 110. So we saw how it just switched out, right? When we automatically configured it. And when we configured the distance on the OSPF process to 85, it boxed out the EIGRP routes, and now we have OSPF, right? So that's basically how that works. Now, debugging, like I promised. We have OSPF reactivated here, but let's do the debugging here, right? So we're gonna go into, and this is where you're gonna learn the, let's click end. This is where you're gonna learn about the hello timers and hello messages. You're gonna see it happen, right? So it's gonna be debug, and if you're not familiar with any command and you want to see how to navigate it, which I'm not too sure about this, but I think it's debug IP OSPF events, right? But we go debug, and we're gonna use the context sensitive help, I believe it's called. So debug IP, right? And then we're gonna go to OSPF, and then events. This is the right command. Debug IP OSPF events. So debugging is on. So now we're gonna see the hello messages get propagated through. Yep, end of hello processing, right? Let me see. You know what? I want to do something real quick. See? Yeah. Received hello from this router in this area, from this interface, from the neighboring interface. That's the neighboring interface, right? End of hello processing. And you see this is happening every 10 seconds. Right? So we see 25, and we got another one, 35, right? 35, 45. You can see from 45 to 55, right? So, yeah, that's the debugging. Let me see if I can do something real quick. I created this crazy network. Just bear with me. As a matter of fact, I can just share. Let me go ahead and share this screen. Yeah, I'm gonna share this screen. Please don't mess up. Please don't mess up. Cause I wanna do something real quick. Let me see. Dang, why is it not showing? Packet tray, no. Ospf property, OBS, Windows server, desktop. What am I doing? What is this doing? No, not that. Doc. I'm fooling around with this in real time because I want to show you something real crazy, and it's pretty much how I pass my CCNA. It's not showing the packet tracer that I want. What should it show it under? Cisco packet tracer. It's not showing. So let me just go ahead and create another window. Let me see if it's gonna show up now. Maybe it's because I have it full screen. Let me see. Bear with me. Bear with me. Let me just first open this up. Show you a few things. And you know what? This is a live stream format, so hopefully you guys are, you know, enjoying this. Hold on, let me see. Cancel. Oh wait, it's showing. All right, let me show you something real quick. Yeah, I think you guys can see that now, right? You should probably be able to see it. So this is the network that I use to set up my to pass the CCNA. So I just created one big master lab and I just did everything in it. So let's see here. The debugging is on. This is what I was saying with the debug. No, the debugging is not on this one. Do show IP route. Let me show you something. See, this is a bigger version of the routing table. See, we have OSPF. These are, and I have the distance set. I changed the default because I had the administrative distance set because I had the EIGRP. I have EIGRP running on this as well. But oops, do not go into that. That's not what I wanted to happen. But yeah, so let's close this out. So I have running right now. As you can see, I have inter-VLAN routing set up on these different routers, on these different switches. So let's check here. See, this is get familiar with this, right? This routing table, it tells you everything you need to know, right? This is a big network that I had set up to learn the CCNA, to get prepared for the CCNA. So yeah, I think that's enough. Probably bored you guys to death, but yeah. So look, let me go back down to here and come back over here. Yeah, I'm getting better with this stuff. So yeah, you can see the OSPF just been processing. The OSPF debugs have just been processing the whole time, right? Look at all of this. And this is using up CPU, it's using up processing cycles and all of that stuff. So you gotta be very weary about how you're using the debug command, right? So yeah, that's pretty much that. So let's recap real quick. Make sure, we gotta do one more thing to verify. So we come to this desktop, and this is all packet tracer. You see it has a static IP. Let's see if Dhcp works. See if I configured it properly. Request an IP. Yeah, Dhcp request successful. That is because of the IP Dhcp pool command that we set. As you can see, everything that I set, the default gateway, the DNS, everything went into the system. All right, let's do it here too. Desktop. Let's see. Hopefully this one works. It does work. So this is 192.168.10.1, right? I don't know what that was. Yeah, 20.1. So let's ping the other one. Let's ping 192.168.10.1, right? 10.1, right? So it's pinging. I think it's gonna work. Okay, there we go. Now, why did the first request time out? Why did the first request time out? It's 4 pings, 3 received, 1 lost, right? So let's do it again. Now all 4 of them were sent. I think you should have learned this already, but if you know the life of a packet, and if you're familiar with the routing process, you would know that that first ping was lost because the host had to send an ARP request to learn its default gateway, right? So basically what happens when a host wants to send a packet that's outside of its subnet, it has to first learn its default gateway's MAC address, right? So essentially, did I say IP address before? I think I did say IP address. Getting tired. But essentially, that host has to learn the MAC address of the default gateway, right? It's default gateway. So if the destination is outside of its subnet. So what it does is it attempts to ping, right? But obviously it's not going to propagate because it doesn't know its default gateway's MAC address. So the way that it learns the default gateway's MAC address is by sending an ARP request. So the ARP request gets sent from here to here, and then it gets sent to the broadcast address of all Fs, right? So all Fs means all devices on this network right here, on this switch right here, right? So it ends up reaching the router, right? So basically the ARP packet says, who belongs to 192.168.10.254, right? And then the router answers back and says, oh, this is me, and it sends the I belong to whatever 192.168.10.254, and it sends its MAC address along with it, with the response to the switch, then sends it to this, then it sends it back up to the router, and it sends it across. And the reason why that happens is because this switch does not understand IP addresses at all. So the PC knows the default gateway's IP address. It knows that it needs to send it there, but it does not know, it doesn't know the MAC address, which the layer 2 switch needs in order to send it to the default gateway. So basically, it sends out the ARP request looking for the MAC address for here. Boom, boom, boom. It sends it out. Boom. It comes back. And then now the PC can send a ping with the layer 2 address of the router, and then it can propagate it across the link. Hopefully I didn't butcher that too much, but yeah, I probably did butcher it. I think you could kind of see it in the I think you can see it here. You can see, I think you, how do you see the packets? Let me see. Let me see. You should be able to see it here. I didn't play around with this too much, so pardon my ignorance over it. So let's see. Let's send a did I send it this way? No, let's send it this way this time. Okay, so 192.168.20.1. Oops. Gotta ping it. Gotta hit the ping command. Expecting the first one to time out. Is it? No? Let's see. It's not, is it not working? If it's not, then we're just about to end this right here because I went in. No, it's not working for some reason. Don't know why. What happened here? Yeah, layer 3. Okay. Yeah, I don't know what's going on here. Oh, is it sending a ping? Is that the ping? Oops. Yeah, let's see, did it respond? Yeah, it did. It did. Oh, well, okay. Well, it responded. All right, anyway, not gonna, we'll save all of the packet analysis stuff for another video, but yeah, that's pretty much it. We had a lot of fun with, you know, fooling around with Packet Tracer, playing with some basic concepts for OSPF. And yeah, that was an 1.5 hour long video, and that was pretty fun. I had fun playing around with the OSPF, the different OSPF commands and the features of those commands. And this is the technical content that I like to do. Maybe next time I'm gonna organize it a little bit better and try not to be all over the place, but it's really hard because I get so excited about networking concepts and all of the things that I learned throughout the CCNA. But yeah, if you like these type of videos, make sure you like, comment, subscribe, comment, tell me what I could do better, what you know, what I did well. Let me know if you're interested in watching live streams, that live streams like this, because again, I'm still working on the format, still getting my practice in, because live streaming is no joke, you know? So yeah, that's pretty much that, and I'm going to talk to you guys next time. Peace.